Okay, so the question we had was, in a class of 30 students, 21 like math, 12 like physics, and 6 like neither. Estimate the number of students who like both math and physics, math only, and physics only. Now, what you would observe here is they did not give you the intersection, which is all the students who liked all of them, or the two of them. So what we would do is we'd assume that X would represent the number of students who like the two subjects. Okay? Because the main thing is that we put into the Venn diagram the intersection, right? That's the first thing we should place in the Venn diagram. So our Venn diagram, which you will draw up first, that will show the intersection of the two sets. Right? We'll have those that like physics and math. So we'll call this one P will represent those like physics, and M those that like maths. U would represent the universal set, which would be all the students in that particular class. Now we know U corresponded to 30 students, and if we say that we let X represent the number of students who like both physics and maths. Okay, that's the first thing we do, and that's how we came up with those two circles there. The X has to be placed here because it would represent those that like both. The other thing that is significant is they say 6 like neither. So it means that that 6 must lie outside here. Right? There are 6 students who would lie outside of the maths and the physics. The other thing they told us was that 21 like math. So if 21 like math, that means in the entire math circle, you would have 21 persons or students. Now if there are X that like both math and physics, then those that like math only will be 21 minus X. And those that they told us, those that like physics were 12. All right, so if we wrote down the number of people that like math, we would have gotten 21 here. And the number of people that like physics, we were told that that was 12. Okay? So what we had deduced was the number of people that like math only, which was here, which is number of people that like math and not physics. Right? We had gotten that, and we got that to be 21 minus X. And the number of people that like physics was 12, so the number of people that like physics only would be physics and not math. That would be physics only. And that would work out to be, if you look here, on this side, in the physics circle, you're supposed to have 12 in total. But if X like both of them, then physics only will be 12 minus X. Okay, so your Venn diagram should be looking something like that to start off. Now, how do we go about actually getting values for the areas? Would be to use the fact that the number of people in the universal set, which is 30, must be made up of all the individual portions added up separately. So you'd have to add up math only, those that like math and physics, those that like physics only, and those that like neither. Okay, so you'd have to get each of those individual areas. Those that like math only, which would be this one. Those that like math and physics, those that like physics only, and those that like neither. And we could form an equation, right? The equation would be 30, which is the total, everything in there, must be equal to 21 minus x plus x plus 12 minus x plus 6. Okay? So you have to add up everything inside of those individual areas so that you will get 30. Okay? So then you have to solve it. You say 30 now will be equal to, you could take the numbers and add them. So you could take the 21, add the 12, and add the 6. If you add 21, 12, and 6, you should get 39. Then you look at the x's. Now minus x will cancel out with plus x. And all you'll have is this minus x here remaining. So we'll have 39 minus x on the right hand side. Now in order to solve for x, we could add x here and add x here. Right? So you'll end up with x plus 30 is equal to 39. Right? Because if we add x on the right hand side, the minus x will cancel out, so you'll end up with 39. And if you add x on the left hand side, you'll get x plus 30. And therefore, x will be equal to 39 minus 30 if we take away 30 on both sides. So we'll get x would be equal to 9. Okay, so the question asks, estimate the number of students who like both math and physics. So this here would have answered part A. Right, this would be the answer for part A, 9 students. That's an answer. For part B now, they asked those that like math only. And we know math only was 21 minus x. So you write math only, which is the same thing as the number of people that like math and not physics, is equal to 21 minus x or 21 minus 9. And 21 minus 9 would give you that answer, which is 12 students. Okay, so the answer there is 12 students. And the last part was physics only. So part B answer was 12 students. And the last one, which is part C, right, where you have to find physics only. That would be equal to physics and not maths. And we know that was 12 minus x. So physics and not maths was 12 minus x, right, which is this, which is equal to 12 minus 9. And 12 minus 9 will give us 3. So we'd have 3 students that did physics only. Okay, and this as well is an answer. Okay, any questions with this? Look at it and see if you have any questions. All right, I'm going to dictate a question here for you and you'll take it down. Okay, this one will involve 3 sets as opposed to 2. It goes like this. In a music class, of 45 students, in a music class of 45 students, 28 students like calypso, 16 like reggae. In a music class of 45 students, 28 students like calypso, 16 like reggae, 28 like soca, 28 like soca, 15 like both calypso and soca, 15 like both calypso and soca, 9 like calypso and reggae, 9 like calypso and reggae, and 10 students like both soca and reggae. And 10 students like both soca and reggae. Full stop. 10 students like both soca and reggae. Full stop. Each student likes at least one of the 3 types of music. Each student likes at least one of the 3 types of music. A. Part A. Draw a suitable Venn diagram. Part A. Draw a suitable Venn diagram to represent the information given. Draw a suitable Venn diagram to represent the information given. Using X to represent the number of students who like all 3 types of music. Using X to represent the number of students who like all 3 types of music. That's part A. Part B. Determine the value of X. Part B. Determine the value of X. Part C. How many students like. Part C. Find how many students like 1. Calypso only. Part C. Find how many students like 1. Calypso only. 2. Reggae and soca only. Part C is find how many students like 1. Calypso only and 2. Reggae and soca only. Okay, so I'd like you to take 2 minutes, 2 to 3 minutes to see what your Venn diagram would look like. So drop what you think your Venn diagram should look like. Use C to represent calypso, R for reggae, and S for soca. C for calypso, R for reggae, S for soca. Put the calypso soca on the left, the calypso circle on the left, the reggae circle on the right of it, and the soca circle down to the bottom of the two of them, right, when you join it. Okay, so in this question, what we do is first of all, we draw the three circles, and these three circles, of course, would be enclosed in a rectangle, all right? So you have your rectangle that would enclose these three circles, okay? And that would represent your universal set, right? This would represent your universal set. And the number of people in the universal set was given to us as 45 students. Right, so you have 45 students there. What we did, they said, let X represent those who like all three types. So you place X directly in the center. The next thing we'll do is we'll start to look at the areas closest to the X. So let's say this area that I'm going to draw out here in blue, right? This one here that I'm drawing out now in blue. This area here would represent those who like calypso and soca. The area that I just drew there would be those who like calypso and soca. And we were told that those who like calypso and soca, there were 15 students. Okay, when they were giving us the information, they told us 28 like calypso, 16 like reggae, 28 like soca, 15 like calypso and soca. So that means that 15 people would lie within that blue area that I identified there. Okay? Because that is the overlap. The blue area is the overlap of calypso and soca. Correct? It's where the two circles overlap. So inside of this area here that we highlighted would be those people that like calypso and soca. And that's 15 in all. But this area here, where the arrow is pointing, will be those that like calypso and soca only. In other words, there's no overlap at all with the reggae circle. So this would be those that like calypso and soca only. And calypso and soca only would be written like this. Number of people that like calypso and soca, and to get the only part you put and not reggae. That's how you get calypso and soca only, by taking out the reggae. Good? So we have calypso and soca, which is this circle, but you're taking out those that like reggae too. And that will be equal to 15 minus X. -X. Okay, so that is how we start to get all the other areas too. Because the same thing we applied for calypso and soca, we could apply for each of the combinations. Okay? So the next one we could look at is those that like soca and reggae. Soca and reggae would be, I'll just highlight it now, soca and reggae would be this one. Right? That would be soca and reggae there, that area. So if we were to concentrate on this part here alone, where the arrow is now pointing, this part here alone, right, that would be soca and reggae only. Soca and reggae only. So if we wanted to get soca and reggae only, we'd write Right, soca and reggae only. It means soca and reggae and not calypso. And what we would do is look at those who like soca and reggae, and that was told to you as 10 students. So to get soca and reggae only, you'd have to say 10 take away X to get the only part. So we write down 10 take away X here. Okay, and the next part we're going to look at is calypso and reggae, which is the one at the top. So to get calypso and reggae only, we have to look at the calypso and reggae intersection, which I'm highlighting with now. That area there will be calypso and reggae, those who like calypso and reggae. But to get those who like calypso and reggae only, which is this area here, that's calypso and reggae only. Calypso and reggae only. That'll be the number of people that like calypso and reggae and not soca. Calypso and reggae and not soca will be those that like calypso and reggae, which we were told was 9. 9 like calypso and reggae. So to get calypso and reggae only, it will be 9 minus X. So this area here would be 9 minus X. Okay? So we start working from the center, come outwards. And that's where we reach so far. The next area we're going to tackle would be the ones that are left blank. So we'll tackle this area first, then this one, then that one. So this area here is calypso only. Right? That's calypso only. The whole circle is calypso. But the area that is unshaded in this area here, that remains without any writing in it, that area will be calypso only. And to get calypso only, what we'd have to do is take those that like calypso, which we were told was 28, and minus from that 28 all of the other areas, which would be this one, and this one within the calypso circle. So to get calypso only, we have to take the total calypso, which we were told was those who like calypso were 28, and minus from that all of the other areas that are included in that calypso circle. So it will be 28 minus 9 minus X plus X plus 15 minus X. And that would give you those that like calypso only. Now calypso only will be written as this. Calypso only will be number of people that like calypso and not reggae sorry. That'll be calypso, and to get calypso only be calypso and not reggae and not soca. That's how you write calypso only. That area there would be calypso only. Right? And when you evaluate this here, the 28 minus all those areas, you would get 4 plus X. When you work out this, you'll get 4 plus X. And in a similar fashion, you'll go ahead and get reggae only and soca only. Okay, so how would we get reggae only now? Let's go reggae only now. To get reggae only, what we do, we'd look at those who like reggae, and they said that that was 16 students. So those that like reggae are 16. But to get reggae only, you'd have to take away from that 16 all of the other areas in the reggae circle to get reggae only. So that would be 16 minus 9 minus x plus x plus 10 minus x. Okay, and that would be reggae only. How do you write reggae only? It'll be number of people that like reggae and not soca and not calypso. That's how you get reggae only. That'll be reggae. Okay? And when you evaluate that and you work that out, you'll get x minus 3. When you work this out, you get x minus 3. That's reggae only. And the last area is the bottom area there, and that will be soca only. So if you want to work out those who like soca only, which means the number of people that like soca and not reggae and not calypso, that'll be soca only. What you'd have to do is go back and look at those who like soca in total, and they said those who like soca in total were 28 people like soca. That means 28 people was in the whole soca circle. But to get those who like soca only, you'd have to take away from that 28 all of those in the areas in that soca circle as well, which would be the 15 minus x from here, the x from there, plus the 10 minus x from here. Okay, and when you evaluate this here, that will work out to be 3 plus x. 3 plus x. Okay? So this is how you go about filling in that circle. Start from the center and work outwards until you have everything all filled out. That will be the answer to step part A. Because part A said draw a suitable Venn diagram to represent the information given above, using X to represent the number of students who like the 3 types of music. So this would be part A, where you would end up with these areas filled in. One area would have 4 plus X. The other one would have 9 minus X. X is already given to us. 15 minus X is what we worked out here. 10 minus X for here. And 3 plus X for that location. So those are the critical ones, or the areas that we'll be looking for. They then said determine the value of X. Determine the value of X. How do we go about determining the value? Well, it is similar to 2, where we have to say 45 would be equal to all of the areas added up together. Right? And then solve that resulting equation. So you write something like 45 will be equal to, and you add up all the areas, 4 plus X plus 9 minus X plus X minus 3, forgot to include this one here, plus X minus 3 right, so we did all this here, then we come down, plus 15 minus X plus 10 minus X plus 3 plus x. Okay, so what we said is this 45 here would be equal to all of the areas added up. The 4 plus x, the 9 minus x, the x minus 3. Right, then we went down to this level, which would be the 15 minus x, the 10 minus x. We added in all of that. And then finally we came to this one here, which is 3 plus x. So 45 will be equal to all of that added up. Okay? And then this here now, when you work this out, let's see what happens. If you add up all the numbers, if you add the 4, the 9, the minus 3, the 15, the 10, and the 3, you will work out, that will work out to be 38. When you work it out, you get 38. Sorry, what am I missing? No, I finished. Yeah. We didn't finish, not 38 alone. Just the numbers added up will give you that. Right? Just now. Okay, so if you add up all the numbers, you will get 38. But then the x's are what we have to consider now, right? Which is x, this x cancels with this minus x. This x cancels with this minus x. This minus x cancels with this x here. So we're really missing an x. Yeah, where's that x? 4 plus x, 9 minus x minus 3. Right, I didn't put any x by itself, which is this one, right? So we have to put in that x, and that's why it's supposed to have x here. So let me just rub off this. That's the x that was missing, which was the intersection, right? So we forgot to add in the x, which is the intersection, which is that x there, right? And when you take that into consideration, the numbers when added up will give us the 38. And when we consider the plus x and the minus x cancelling out, all you'll have is this plus x at the end. Okay, so you'll get 45 is equal to 38 plus x. And then all you have to do now is solve that equation. If 45 equal to 38 plus x, then it will mean that 45 minus 38 will be equal to x. 45 is equal to 38 plus x when you add up the numbers and you cancel the x's. And therefore, you could now find out what the x is equal to. This would mean that x will be equal to 45 minus 38, which is 7. 7 students. Okay? So all that will be really part B. And then for part C now, where they ask us to find out two things. One, calypso only, and then reggae and soca only. Now, calypso only is what we have up here. And calypso only was 4 plus x. So if you write down calypso only, which is number of people that like calypso and not reggae and not soca, we could obtain that by using 4 plus x. So it'll be equal to 4 plus x, which we got as 7. 4 plus 7, which is equal to 11 students. So the answer here will be 11 students. Good? And then the last part, which is C part 2. This was C part 1. C part 2 now. In C part 2, they wanted us to find out those that like reggae and soca only. Reggae and soca only will be where? Reggae intersecting with soca only. Soca and reggae only is 10 minus x. Okay, soca and reggae only is 10 minus x. So how do we find that? Simple. We write down what they want us to give us. So part 2, number of people that like soca and reggae only, which means soca and reggae and not calypso. And we know that that is 10 minus x from here. So we just put in the 10 minus the x. In this case, x was 7. And that worked out to be 3 students in all. 3 students. Okay, so your final answer there was 3 students. So your answers would be, first of all, the Venn diagram. Right, that'll be part A. Part B, your answer worked out to be 7 students. This was the answer here. And part C, you had 2 answers. One was 11 students, and the other one was 3 students. Okay. Okay, so we had these questions here as a previous assignment, and we're just looking back at 2 of them to see how it goes. This is an example of solving simultaneous equations where one equation is linear and where the other one is nonlinear. Right? Equation 2 is the linear equation. Equation 1 is nonlinear because it contains a squared term. You have x squared. All right? The procedure there would be to get one variable in terms of the other. Either get x in terms of y or y in terms of x. Now in this case, equation 2 already has y in terms of x. In other words, y is the only thing on the left hand side, and y is expressed in terms of x on the right hand side. So y is equal to 7x plus 5. So already in equation 2, we have y in terms of x. So all we have to do is substitute y equal to 7x plus 5 into equation 1. So that's what we'll do. We'll substitute y equal to 7x plus 5. We substitute that into equation 1. Let's see what happens when we do that. In equation 1, we will get, instead of y, we will replace it with 7x plus 5. So instead of writing y here, I'll write 7x plus 5. Because y is now being replaced by 7x plus 5. That will be equal to 2x squared plus 1, like this. And then we'll turn this now into a quadratic equation. How you turn that into a quadratic equation? Get one side equal to 0, right? And let the other side represent the quadratic equation. In order to do that, what I'll do is I'll remove 7x and 5 from the left-hand side by minusing 7x and minusing 5 on the left-hand side. That means I'll get 0 if I take 7x away and I take 5 away. But if I do it on the left-hand side, then I must also do it on the right-hand side, which means I must minus 7x and I must minus 5 on the right-hand side as well. So the next step now will be to simplify the right-hand side. So I'll get 0 is equal to 2x squared. I'll bring the minus 7x up, and I'll combine the plus 1 and the minus 5 to give me minus 4. So in that way, I would have created a quadratic equation. The 2x squared remains. This minus 7x, I just bring it closer to the 2x squared. And the 1 and the minus 5 gives me minus 4. What I will have to solve here. Now this is a quadratic equation where we could use the method of factors. Let's see what will happen if we find AC and we compare it with B. AC will be 2 multiplied by minus 4. 2 multiplied by minus 4, which will give me minus 8. I therefore have to find the factors of minus 8 that when added together give me B. In this case, B is minus 1. B is minus 7. So I'd have to get the factors of minus 8 that give me minus 7. And once you try it, you'll see that 1 multiplied by minus 8 will give me minus 8. So these are two factors of minus 8, 1 and minus 8. And if I add 1 and minus 8 together, minus 8 plus 1, you'll see that that will give me minus 7. So the required factors are 1 and minus 8. Therefore, the required factors are 1 and minus 8. So that is critical, because now we could come back and say 0 is equal to 2x squared, and instead of writing minus 7x, we could use these two factors, which is plus x, that's 1x, minus 8x. Minus 4. Okay, so 2x squared minus 7x minus 4 could be replaced by 2x squared plus x minus 8x minus 4, where we replace the minus 7x by these two factors here with x. That one will be 1x, and this minus 8 here will be minus 8x. That will replace the minus 7x. So we could go ahead and we could factorize this by grouping, by taking out x. We'll get 2x plus 1. And from the second pair, we need to get 2x plus 1. And therefore, we need to take out minus 4. If we take out minus 4, we will get 2x plus 1 in brackets here. And that was important because now we could write 0 is equal to 2x plus 1, x minus 4, like this. Okay? Because we take out 2x plus 1 as a common factor, and from the first pair we'll get x coming here, and from the second pair we'll get minus 4 coming here. Now, that would say that either 2x plus 1 is equal to 0, or it will say that x minus 4 is equal to 0. So in this case, if 2x plus 1 is equal to 0, it would imply that x would be equal to minus a half when you solve that, or x will be equal to 4. How we got the x equal to minus a half? I did two steps there in one. If 2x plus 1 is equal to 0, then 2x is equal to minus 1, and then the next line will be x is equal to minus 1 over 2, or x equal to minus a half. So these are the two solutions for x. We now have to find the values of y. Find the values of y by substituting the values for x into equation 2. So we'll substitute x equal to minus a half in equation 2. And what will we get? If I take x equal to minus a half and put it in equation 2, I'll get y is equal to 7 multiplied by x. Sorry, 7 multiplied by x, which should be 7 multiplied by minus a half, plus 5. What that will give me, y will be equal to 7 by minus a half is minus 3 and a half. Plus 5, and that will give me 1 and a half. Okay, so what I did was take the one value of x, which is equal to minus a half, substitute it into equation 2. So the x here becomes minus a half, which is here. Work that out, and that would give me one value for y. But then there's another possible value of y, because x is also equal to 4. If I substitute x equal to 4 now, again into equation 2, what will I get? I'll get y equal to 7 multiplied by x. X in this case is 4 plus 5. What will that work out to be? 7 4s are 28 plus 5. 28 plus 5 is 33. So another value of y is equal to 33. So what we do as usual is we'd write our answer. If we were to write the answer here, just for space constraints, what we normally do is make up a nice box that would have the possible values of x and y, and we write that in. So if we come back here, we see that when x is equal to minus a half, we worked out that y was equal to 1.5. When x is equal to minus a half, we got y was equal to 1.5. So you write it down here. And then we got when x was equal to 4. When x was equal to 4, we got y is equal to 33. Okay, so we have a question on the board. X squared plus y squared is equal to 144. And x plus y is equal to 9. They ask us to find x minus y in part 1. And then x squared plus y squared minus 2xy. Now sometimes in an exam, they will give you a question that looks as if it's supposed to be done one way, when in fact they require you to use knowledge that if you use that knowledge, you will solve it in a much simpler manner. Now this could be solved by using a quadratic, by using a simultaneous equation technique similar to what we just did, which was to get x in terms of y or y in terms of x and substitute into the top equation. We would have said, for example, y is equal to 9 minus x from the equation below, second equation. So if this was equation 1, and this one was equation 2, what we would have said is, from equation 2, we could find that x is equal to 9 minus y, or we could have said from equation 2, y is equal to 9 minus x, and then take that value and substitute it into the top equation. Go through the whole process that we did just now, form a quadratic equation, and solve it. Okay? It would have been a very elaborate solution, to say the least. Right? However, there's another way to do this, which is actually a much more powerful way, because it utilizes other things that you know. Now, in an exam, they won't tell you how to solve it. They just tell you solve it. So you have to use your knowledge, all your maths knowledge, and make it as easy as possible for you once you know it's correct. And the method that I would use here is this. I would first look at what they want to find. They want us to find x minus y. They want us to find x minus y. Now, that's all. Okay, so there was a mistake here, right? It's supposed to be minus x squared minus y squared. And based on that, we should be able to work this out. Okay, now x squared minus y squared is the difference of two squares, isn't it? And that's what you have to recognize. Now when I was checking it initially, I was realizing that something wasn't quite as it's supposed to be to solve this in an easy way. Now, if we recognize that x squared minus y squared is the difference of two squares, then we could write this. X squared minus y squared is equal to x plus y, x minus y, not so? Because the difference of two squares is the product of the sum and the difference of the two numbers squared. So we could write that using the difference of two squares. But in equation 2, they told us that x plus y was equal to 9. Good? And x squared plus y squared is equal to 144. Sorry, x squared minus y squared is equal to 144. So if I know x squared minus y squared is 144, can I write 144 here for x squared minus y squared? That'll be okay. Then they also told me that x plus y was 9. So I could also write 9 for x plus y here. Correct? So the only unknown that I have is x minus y. And that is what they want us to find in part 1. So to find x minus y, I could say 144 divided by 9 is equal to x minus y. Divide 9 on both sides. That's the answer for part 1. So you realize in this case, we didn't have to go into any solving equation techniques like we did before. All we had to do is recognize that this is the difference of two squares, and they gave us enough information otherwise to solve for what they wanted us, which is this. Sometimes they do that in exams. They give you something that seems to be done one way, but if you use knowledge from other things, you could solve it much easier. This is a very, very good example of that, and that's why I brought it for you all to look at. Okay? So that's one part. We also have to look at part 2 next, which is a very critical part. In the second part, you have to find x squared plus y squared minus 2xy. Now, if you had certain previous knowledge, you would be able to easily solve this problem. And this is the knowledge I'm going to give you now. The knowledge is this. If you had to expand x plus y all squared, you could expand that by saying x plus y multiplied by x plus y, like this. Okay? And to expand that, you would say x by x, x by y, then y by x, y by y. That's how you expand it. The first one by the 2 inside the brackets, the second one by the 2 inside the brackets, and you would work that out and simplify it. But there's something that you could do now. Instead of actually working out, you could memorize what it is equal to in an easy way. And it will be helpful not only in this case, but in many other cases. And the easy way is this. X plus y squared could be found by squaring the first term, whatever it is. In this case, it will be x squared. Squaring the second term, which will be y, so it will be plus y squared, right? Plus 2 times whatever the first term is, which is x, times whatever the second term is y. And I would like you to commit this to your memory, because it will be very helpful. We'll do it here. We'll see how it's used here just now. But this is how you learn this easily. Anything in brackets like this, x plus y squared, square the first term, which is x squared, square the second term, which is y squared, and add 2 times the first term times the second term, which is plus 2xy. If it's minus, like x minus y squared, it's similar. It'll be x squared plus y squared, and instead of putting plus 2xy, you'll use the minus here, it'll be minus 2xy. You could expand this by doing the same thing we said up there, which was x minus y multiplied by x minus y, and you go through the whole process. You could do it, no problem. But it's very powerful and useful to you if you memorize these two, right? And I'll show you how it's useful here now. You'll see how very useful it could be in this case. Okay? Now, how could it be useful here? How could it be useful here? Because if you look at this, without this knowledge, this wouldn't make any impact on your brains. But if you now have this knowledge, you could see that this is the same thing as this. Because you have your x squared, you have your y squared, and you have minus 2xy, which is what I have here. So this could be written like this, because it's the same thing. So I could write that x squared plus y squared minus 2xy is equal to this, x minus y all squared. Why is that useful to me in this case? Here's why. Because in the previous question, they asked me to find x minus y. And x minus y we found to be 144 over 9. So x minus y squared will simply be 144 over 9 squared. Because x minus y is 144 over 9. So if you want to find x minus y squared, that's 144 over 9 squared. And this is what they wanted us to find. This here is x minus y squared. We already know what x minus y is, so all we have to do is square it, and we'll get the answer that they want, whatever that works out to be. And that's the answer there. Just put in the calculator, square it, and you get your answer. So what I'm saying to you here is that previous knowledge, which I gave to you today, right? I gave you it in sequence here, will help you to solve questions sometimes that seem very, very long-winded. You could do it by having previous knowledge. Okay, so you'll use this technique where applicable. But the key thing here is to learn what x plus y squared is in terms of the expansion. Learn what x minus y squared is in terms of the expansion. But what is also useful to note is if they had put p plus q squared, does that mean that we don't know how to do that? It follows the same pattern. What will be here? P squared plus q squared plus 2pq. It doesn't matter the letter. It's just the pattern. What about if they use r minus t squared? What do I put there? R squared plus t squared, and then what I write at the end? Minus 2rt. Am I a genius? Are you a genius? No, you're just aware of what it is. You're just aware of what it is. Okay? So be guided accordingly. So if we had actually worked on this 144 over 9, it worked out to actually be equal to 16. Right? That 140 over 9 is 16. And this worked out to be 16 squared, which worked out to be 256. Just in case you didn't work it out. Right? It looked funny, but actually putting it in the calculator, you see it worked out to be something easy. Okay, so we close off with some brief notes on relations and functions. And the first thing we write down is what is a relation? A relation is defined as a set of ordered pairs that obeys a particular rule. A relation is defined as a set of ordered pairs that obeys a particular rule. Full stop. The relation may be one-to-one. The relation may be one-to-one. Many-to-one. one-to-many. A relation may be one-to-one, many-to-one, or one-to-many. Okay, that's note 1. Note 2 now, below that you write, a function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. Okay, starting over. A function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. Is mapped onto one and only one element in the range. Therefore, it may be one-to-one or many-to-one. Therefore, it may be one-to-one or many-to-one. Okay? Below that you write, for a function f, below that you write, for a function f as in fan, right? For a function f, and any element x, for a function f and any element x in the domain of f, and any element x in the domain of f, comma, the image of x is denoted by f open brackets x close brackets, like on the board, f open brackets x close brackets, which is pronounced f of x, comma, where x and y equal to f of x, where x and y equal to f of x, like on the board, are variables. Where x and y equal to f of x are variables. Full stop. We can use the function notation. To find the image of x. We can use the function notation to find the image of x. That is, we can use the function notation to find the image of x. That is IE, right? You could use IE. The value of f of x. the value of f of x. We can use the function notation to find the image of x, i.e., that is, the value of f of x. We can use the function notation to find the image of x. To find the image of x, i.e., the value of f of x for a given value of x. For a given value of x. So if we had an example, if f of x is equal to 2x squared minus 3x plus 1, find the values of one, f of minus 3, 2, f of 0, and 3, f of 2. In order to do this, all we have to do is replace in f of x, wherever we see x, we replace it with the number. So let's say we have to find f of minus 3. All we have to do is take out x in f of x and replace it with minus 3. That's all. So if f of x is 2x squared minus 3x plus 1, all we are going to do is replace this x with the minus 3. So it's going to go inside of there. So what we'll have is 2, and instead of x squared, we'll write minus 3 squared. Instead of this x squared, we'll put minus 3 in its place. Then minus 3 multiplied by x. Instead of x, we'll put minus 3. Plus 1, plus 1. Then we work that out. This will be 2 minus 3 squared is 9. Minus 3 by minus 3 is positive 9 plus 1. So this becomes 18 plus 10. 9 and 1 is 10. That is equal to 28. So therefore, f of minus 3 is equal to 28. That's the first answer. Any questions there? All we do is we take out the x and replace it with the number. Minus 3 replaces x in each part. And then you evaluate the expression or the equation. In part 2, we have to find f of 0. So all we'll do is put 0 in place of x in this case. Same thing, just replacing the x with the number. So it will become, across here, will be 2 by 0 squared now because 0 is replacing x. So it will be 2 by 0 squared minus 3 by, instead of x, we put 0. So be minus 3 multiplied by 0 plus 1. Plus 1. So this is how it will look. Simple like that. So then we come back and say 2 by 0 squared is 0 minus 0 plus 1, and the answer is 1. So f of 0 is 1. That's the next answer. Okay, it's as simple as that. And then the third part, same thing again. F of 2 simply means place 2 for x. So it becomes 2 multiplied by 2 squared minus 3 multiplied by 2 plus 1. X is replaced by 2 in this case. So this will be 2 multiplied by 4 minus 6 plus 1, which is 8 minus 6 plus 1. Therefore, f of 2 works out to be 3. Okay? So we'll close with that for today.